Our next guy here is from the TU Munich. He does electric engineering and information technology. And the next presentation is about visual haptic media communication. And it's called Hello, Can You Feel Me? By Rahul Chaudhari. Yay!
Hello everyone. Can you hear me? My presentation is titled Hello, Can You Feel Me? And I am Rahul Chaudhari from the Institute for Media Technology at the Technical University of Munich. I am going to talk about haptics, which is the sense of touch, and haptics technology that is going to change our daily lives in the future. So let's begin with a story, as my previous colleague did. The story starts in Germany, more specifically in Munich, where we have the beautiful Frauenkirche, the BMW, the Olympia Tower, and of course the Alps. And that's where me and my wife, we live, and we love living in Munich. Yeah. Almost on the other side of the world, that's my home country, India, and the city of Delhi in the north. We have the Taj Mahal very close by from there, and we have the India Gate, and of course lots of IT parks. And that's where my favorite auntie lives. That's my uncle on the right, and that's my cousin at the bottom. So let's fast forward to October 2015. The Oktoberfest is on, and my wife is really excited about it, as always. And she is telling my auntie all about it on the telephone. And we didn't think that my auntie would take it so seriously, but she actually plans on joining us for the Oktoberfest. So she takes the next Lufthansa from Delhi to Munich. And unfortunately, my cousin cannot join her because she has school to attend and my uncle has to go to work. But he's really happy because he thinks that he can rule the house now like a Maharaja, now that his wife is gone. And that's my wife, me, and my auntie before we go to the Oktoberfest. And that's the Oktoberfest. So we go there and we have lots of Brezel and beer tents and all those crazy rides, and we enjoy a lot. And but my auntie is really sad because her family cannot be with her. So she decides to make up for her absence by buying some gifts for her family. So she goes to a shop at the Oktoberfest and she buys a teddy bear toy for my cousin. And in the evening, we are back home relaxing, and my wife has an idea. She says, why don't we do a audio-video teleconference over the internet with my auntie's family in India? So we could show my cousin her toys, and she could enjoy her toy. So we set up a computer, and we install a web camera and a microphone, and we put the teddy bear in front of the computer. And that's my cousin on the other side in India looking at her toy, and she's really happy about this. So I know my cousin really well, and I think she's a very impatient kid. Whenever you buy something for her, she wants to touch it, she wants to feel it, she wants to play it with her hands. So could I give her this? How about if I could transmit the sense of touch over the internet, just like we transmit audio and video? So how do we do this? We take a specially designed or manufactured small robot, and we mount it with some sensors, and we put this robot in contact with the teddy bear. And we call this the German robot because we place it on the German side. So you can see that it is now touching the teddy bear. Now, my cousin has, on the Indian side, her own robot, which she uses to control the German robot. Okay, so she controls the movements of the German robot, which touches the teddy bear and captures some touch signals, which are then transmitted back over the internet to India, and she can actually feel her new toy through her own robot. So this is an example of how this would look. The gray ball that you see here is my cousin controlling the German robot, and it is touching the teddy bear, and she can feel its body. So she can feel the forces that you normally encounter when you touch objects in your surroundings. So for the first time during this presentation now, let's look at the technological side of this situation. This is the communication link between Munich and India. What you see on the top left-hand side is the web camera capturing the visual scene. And the scene that it captures is packaged into packets, so video packets which are marked V here. And similarly, the microphone on the lower left corner is capturing the speech signal, and this speech data is then packaged into so-called audio packets marked A here. Then you see some blocks called compressor on the right-hand side. Basically, what these blocks are doing is that they are squeezing the audio and the video packets into smaller, reduced size packets so that they can fit through the internet. Okay? And there's one more line of signals that you see at the bottom. That's the robot that we are using to transmit the touch signal. So there are also touch packets being transmitted over the internet. On the right-hand side, what you see is a funneled pipe, which is actually a simplistic model of the behavior of the internet. What it basically says is that you can fit at any given time only a limited number of packets through this pipe. Okay? So let's run this simulation and see what happens. So, So the packets start transmitting. They arrive at the entrance to the internet, and you can see that it gets really, really crowded there. And this police officer that you see up there is then deciding that, okay, I don't want to let this packet through, and I don't want to let that packet through. And you can see that some packets are then thrown away. Okay? So those packets in red are being thrown away. So what is the effect, or what is the consequence of throwing away information? You basically distort your audio, video, and touch signals. Okay? So for instance, my cousin sees with her eyes a soft-looking teddy bear, but she actually feels like a stony teddy bear with her hands. This is the result of this distortion. Okay, so that's a bit exaggerated probably, but you get the point. So strange things like that could happen. So now probably you noticed in the last animation that there was a compressor block for the touch signal missing. Now we add that here. Okay, and what it is doing is that basically it reduces now the size of the touch packets into smaller and smaller packets. And the idea is that whenever all these packets arrive at the entrance to the internet, that there will be less of a crowd now at the entrance, and we won't have to throw away as many packets as we did before. So let's see what happens now. So these packets are arriving at the entrance to the internet, and you can see that only a few packets are being now sent to the trash can. Okay. So we are throwing away much less information than before. And now that is improving our quality, and so my cousin can now actually feel a soft teddy bear when she sees a soft teddy bear. So she gets a coherent perception of the teddy bear now. So what's the magic inside the touch compressor? What is happening inside? So what you see on the top left-hand side there is our German robot. Below that, you see the touch signal, this wavy pattern. And those vertical lines on the touch signal are marking points on this wavy pattern, and each of those points needs to be transmitted over the internet to the Indian side. Okay? Now what we do in the compressor is that we collect 40 of these points together, and we process these numbers on a computer using an algorithm, and we extract a mathematical model of the signal. So basically this model is modeling the wavy behavioral pattern of the touch signal. Okay, so this is the model that you see here. And this model basically produces a synthetic touch signal, which is an approximation to the original touch signal. And since this is a model, and no model is perfect, so these two signals are not exactly the same. There is some difference between the two. One more thing that you should notice here is that we started off with 40 numbers, but now we are down to 10 plus 2 plus 2, 14 numbers, 1, 4. So it's going from 40 to 14. And this is how we are achieving compression. Okay? Now the important question is if the synthetic touch signal is close enough to the original touch signal, because if it is not, if the difference is too large, then you will not get a natural touch feeling. So is my cousin able to perceive this difference or not? That is the question. And how can we ensure this? We basically model the processes in the brain of my cousin. Okay, not my cousin, but we do lots of human subject studies. And we come up with a touch perception model. So this is now the second model that actually helps the signal model to tune its own parameters so that the signal model can improve the quality of the synthetic signal. Okay? And this is a repetitive process. This goes on again and again until the time that the touch perception model decides that, okay, now the difference is not perceivable, or my cousin cannot feel the difference between the two signals. So with that, we have what I have described are first steps towards a technology that leverages the power of the internet to provide not just high-quality audiovisual communications, but also real physical touch-based interactions. And this is the future of interactive multimedia. With that, I come to an end of my presentation, and I thank you a lot for your attention. Thank you.
Yeah, excellent.